Okay. So this was the problem. Okay. The problem was I gave you this simple RC low pass filter, and because I named it low pass filter, people thought that I wanted the V out as a function of frequency. I did not want V out as a function of frequency. I clearly state down here, plot the simulated V out of t, the voltage function of time, both the simulated and the theoretical on the same graph. Okay. Now, what's the first step? What's the first step in getting the theoretical?
You mean for solving the problem?
Yes, we're getting the theoretical V out of t.
But convert everything to phasor. The values to phasor.
Yes, very good. Convert everything to the phase of the main. Convert everything to the phase of the main. Okay. So VI of t becomes VI phasor, and VI phasor is this. That's VI phasor, and I'm actually doing Mr. Pinto's problem. His number is 7K. Okay. So the 7K remains 7K. The capacitor becomes the impedance of the capacitor. How do we find the impedance of the capacitor? Okay. How do we find the impedance of the capacitor? The impedance capacitor is negative J, 1 over omega C. What is omega? Omega is a frequency, the angular frequency of the applied voltage, 2000 pi. The capacitor is 10 to the minus 6. And so the impedance of the capacitor becomes negative J, 159.2. Okay. Then we use, then what else? What do we do after that? So we got the phase of the main equivalent. What do we do after that?
Find the total impedance.
No, folks, we long past that. We could find the total impedance, but we're beyond that.
Find current now.
We're beyond that. You can't find the current without finding the total impedance.
You say we're beyond. I don't say we're beyond it.
Yes, we are beyond that. We could use another rule that'll get the answer quickly.
V out equals negative J 159.2 ohms over, that would be 7,000 minus J 159.2 ohms times 10 angle 0.
What law is that? Right. What law is that?
I ain't sure. I know the working though.
Yeah, you got to do better than that though. Okay. You got to know what you're doing. That's the voltage divider rule. The voltage divider rule. The voltage across the capacitor is the impedance of the capacitor divided by the sum of the impedances times the supply. That's this. Okay? That is this. V out over VI is the impedance of the capacitor divided by R plus impedance of the capacitor, or what you just said. There's the working. Okay? And then we go for V out. Okay? V out, we have to multiply this by VI. And there is V out phasor. There is V out phasor. Any questions so far? Okay, now that we have V out phasor, what do we do? Now that we have V out phasor, what do we do?
We need to put it back.
Sorry, you were saying something? You got
Do we
cut
put it-
off?
Do we back in the time? Do we put it back in the time domain?
Yes. V out of t. So V out of t becomes V out of t. V out of function time. Oh, I have it right over here. This amplitude becomes that amplitude. It's a sine. There's our input frequency, and there's our output phase. So this is the theoretical V out of t. That's the theoretical V out of t. All right. Now let's simulate that. Let's simulate that. How are we going to simulate that? What do we need to simulate that?
You mean what value is?
I mean, what is the source going to be?
Or sine wave?
Because believe it or not, people didn't even get the source right.
What do you mean? Alternating current source for sine wave?
No, it's a sine wave.
I mean,
It's
yeah,
not,
a voltage
it's
source.
not AC. It's not AC. It's not the AC source.
P sine.
It's
Right,
a
okay.
sine wave. You have to put in the parameters for the sine wave. You can't do that with the AC source. The AC source only gives you one the amplitude. It doesn't let you put in the frequency.
Okay. Oh, okay.
You have to put in V sine. And when you put in V sine, you have to put in V off. We have to make V off equals 0. We have to make VI. We have to make the amplitude 0.2274. And what do we need to make the frequency in hertz? What do we need to make the frequency in hertz?
Need a mega.
And how much is that? The frequency in hertz,
It's 1,000. 1,000.
1,000 hertz. 1,000 hertz. 1,000 hertz. So let me stop sharing a second.
Did y'all use a common range when y'all was picking the frequency hertz, or did y'all?
What does that mean? Excuse me. What do you mean? What do you mean a common range? What does that mean?
So like,
Go ahead. Sorry.
I wasn't sure if y'all was just picking a range.
Yo man, what is our input? Tell me in English what our input is.
I see 2,000.
No, you see 2,000 pi. You see 2,000 pi apples. You see 2,000 pi what?
2,000 pi T.
2,000 pi what?
T. I don't see nothing else up.
Radian.
Radians per second.
Right, radians. Yeah.
Radians per second, but PSpice don't want you to put radians per second here. PSpice want you to put frequency in hertz. And what is 2,000 pi's radians per second in hertz? It's 2,000 pi. It's 2,000 pi divided by 2 pi, which is 1,000 hertz. So am I sharing? Hold on a sec. I want to be sure. Yes. Am I sharing my diagram, my PSpice diagram?
You share in your email.
That's the email.
Oh, you're not seeing the what's on?
No.
All right. What about now?
Yeah, we can
I see.
see it now. No,
Okay.
that's no.
No.
Yeah, it's yeah,
It looks
Okay.
like a picture.
right.
Yeah, it is a picture.
Right.
It is a picture. It's a picture. It's a picture of the PSpice diagram, which all of you should done. All of you. The only difference that you have that you had is R1 would have been different for each one of you. That's the only difference. You need a V off. You need a V sign. This is V sign. You need a V off equals 0. You need a V amplitude to be 10 volts, and you need the frequency to be 1,000 hertz. All of you. The only difference was R1 for Mr. Pintar is 7K, and for Mr. Anderson, I think it's 1K. This is a diagram that you should have simulated.
Thought I got right.
Yeah, go ahead.
You see when you about to simulate the circuit on PSpice, they ask for different things. So they ask for the amplitude, they ask for the offset and the frequency, right? I want to know
That's for V sign. That's
right,
for this particular problem. Yes.
right. That's for this one, right?
Yes.
Right. That's also I want to know when they have a slot would say AC. What they mean by AC?
Mr. Is this Mr. Pindot?
Yes, sir.
Mr. Pindot, I'm not going to teach PSpice to you. That's
No,
what I do. That's what I do in 235.
The graph still come out the same, no daughter guy. I just wanted to know.
No, it didn't come out the same. I can show you what the graph came out as. They don't come out the same. Right. Now, you stop sharing. And let me show you now what it came out as. Oh, I don't know why. Oh, that sucks. All right, give me a second here. Let me see if I can download it again. The problem is my PSpice is not working on this computer. It works on my other computer, but not this computer. But I need this computer here for my Zoom. Oh, that's a bitch. I wonder why it's doing that. Give me a second, folks. I had this set up. All right. Now, let me see if I can share that. All right. Do you see the green graph?
Yes, sir.
All right. What is the green graph? The green graph is V out of T. That's the simulated V out of T. What's the red graph? The red graph is our calculated theoretical sine wave. Okay. And what do you notice? They're not quite the same. Initially, they're not the same. And then eventually, again, you see that the red and the green eventually combine. And I can see it better on my computer than you can see it. Okay. So down here, see the green is V out. That's V out of T. The red is what? That's the theoretical sine wave we just derived. And what's the moral to the story? What did I want to show you about this? I want you to show you that what we did in 235 is not the complete truth. What I showed you in 235 is the sine wave that we calculate theoretically and the complete sine wave are two different things, but they eventually become the same thing as time goes on. And that's the purpose of this class. That's the purpose of 320. To teach you how to get the green graph with it, which is the true graph. All right.
Question, Mr. Dr. Carter.
Yeah, go ahead.
I see you have like the V out of T, the time domain. You just put that in PSpice just like that and give you the theoretical graph?
I put that equation in, yes, and gives me theoretical graph. Just like I plot V out of V0, I go to plot. I don't put V out of V0 there. I put this equation there.
Okay, you just drop the equation and it'll.
Yes, I notice I don't use T. I use time. I explained this last class.
All right, I'll have to try.
Some of you are not using the PSpice version I told you to use, and you can't do that. And I can take off marks when you can't do that. Because one of the reasons why we use this version is because I want you to show you the equation of what you're simulating. Okay. Now, the truth of the matter is this equation is only part of the answer. Let me go now to my next screen. What do you notice in the screen? What do you notice? The green and the red are the same. Believe it or not, that's green there. The red is right on top. The red is right on top of the green. So what does that mean? Let's go down here. Let me show you what I'm plotting. I'm plotting the green. That's the simulated V out of T. And I'm plotting this addition to our sine wave. It's an exponential function. This entire equation is a true equation in that circuit. The purpose of this course is to help you get that true equation, the entire equation. That's part of the things we're gonna be doing in this class. Any questions about that?
Dr. Goddard, you think you could say the reason why one more time the equation is showing up on your screen?
Because I put it there.
You manually typed it there.
Yes. When you say to plot the green, when you tell it plot V of V0, tell it plot but don't choose a voltage or current. Just type in the equation.
Okay.
And if you're using version 9.1, you can do this. If you're using some other version, I can't help you. Okay. But there's no reason why you can't be using version 9.1. Okay. Any other questions? All right. Now, that's one thing. That's one thing where this cost is different. Another thing is this. What was my input signal? What was my input signal for the circuit?
A sine wave.
A sine wave. So in 235, we all learn how to get the output when the input's a sine wave, because that's what phasor. Phasor only works for sine waves. Phasors only work for sine waves. Now, suppose my input is the square wave. How am I going to get the output? Well, you don't know. You don't know because you haven't been taught. That's what this course is all about. That's another thing we can do in this course. Okay, so two things so far. We get the true output when the input's a sine wave. We get the output when the input is not a sine wave. Okay. And related to this is, how does capacitor behave with respect to voltage? Let me stop sharing for a second. Okay, who all is here? 9 people are here. Okay, let me get a shot. Let me get a screenshot. Okay. Turn your cameras on, please. Let's get a screenshot.
Dr. Cartwright,
Yes.
I just have to connect my phone to turn my camera on because my laptop camera doesn't work.
Okay.
So 1 second.
I don't think I like this computer. My other computer was completely better. All right, smile. Okay, thank you. Let me just save this. Save as, what's the date? 24. Okay, you can turn your cameras off. Okay. How are these related? How is V related to I?
How is V related to I?
I asked you first.
V is equal to I times R.
Yes, V of T. V of T equals I of T times R. How are these related?
Would V of T be equal to I of T times the impedance of C?
No. Impedance isn't in the time domain. Impedance in the phase domain. Impedance in the phase domain is V phasor equals the impedance of the capacitor times I phasor. But this is only true for sinusoid because phases are only true for sinusoids. I'm not asking this question. This is not the question I'm asking. I'm asking how V of T. By the way, I'm discovering from the homework assignments you sent me, you all don't know what V of T means. V of T means voltage is a function of time. And so there was at least one person who wanted to tell me that V of T is equal to a constant in that homework. V out of T equals whatever it was. Let's say 5 volts. That's complete nonsense. The output's a sine wave. So your equation got to be a sine wave. Nobody can even guess what VFT is. Look at this.
Hold on, Dr. Guy, what's the question you're asking right now?
I'm asking how's VFT related to IFT?
In the second with the capacitor, right?
Excuse me? Yes, in the capacitor.
Like how the voltage changed with like by the time, like by the like at a
What is
particular
the
time.
mathematical relationship between VFT and IFT? Just like up here, I have a mathematical relationship between VFT and IFT for resistor. I'm asking the same question, but for the capacitor.
The current divided by the charge is equal to the change in voltage divided by the change in time. Or the current is equal to the change in voltage.
Here's what I expect you to say. VFT equals VIFT. That's what I expected you to say. I expect you to say V of T is voltage cross capacitor equal to capacitance times the current through it. That's what I expect you to say, but that's wrong. The voltage is not proportional to the current in a capacitor. Okay. I of T equals C to V dt. That's the relationship. I of T equals C, the first derivative of the voltage. The first derivative of the voltage with respect to time.
My letter
Excuse me?
with the email with permission, right?
Mr. Pindod.
I sent all y'all. I sent you. I sent the PS. I sent them again.
Oh, okay.
That's one.
But I'll double check.
Okay.
Because I was-
That's one. I can resend though. Okay.
Mr. Pindod, we don't need your business.
Sorry about that.
I of T equals C to VDT. What is the VDT? It's the first derivative of voltage with respect to time. See, this is a calculus-based course. And there's one student who's trying to get in here and not know calculus. Okay. The VDT means how quickly the voltage is changing. The current through a capacitor does not depend upon the voltage across the capacitor. That's what this equation is saying. This is saying the current through a capacitor depends upon how quickly the voltage is changing. All right? So, what's I of T equal to? What's I of T equal to? I of T equals C to V dt. How quickly is the voltage changing? How quickly is the voltage changing?
How quick? How you didn't put a value for time?
You really need a value for time?
It doesn't look like the voltage is changing.
Excuse me?
It doesn't look like the voltage is changing.
Okay, the voltage is not changing. So how quickly is it changing? So what's the value? What's the value of dVdt?
0.
0. 0. So if we put this voltage, by the way, what kind of voltage is this? What kind of voltage is this? What kind of voltage does not change with time?
DC. DC.
Yes, this is a DC battery. This is a DC battery of 12 volts. So you put that DC value of 12 volts across capacitor. How much current flows? 0 amps flows. Why? Because I of T equals 10 C times the VDT, okay, which by observation is 0. 0 amps. Okay. Let me show you can do that mathematically. Mathematically, you say V of T equals 12 volts. Then what's the derivative? What's the first derivative of constant? That's d dt of V of T. That's what the VDT means. If you remember your calculus, except that in calculus class, you use an x's. In this class, we're using t's. Okay. So this is the derivative of what? 12 volts. What's the derivative of constant? The derivative of constant is 0. Any questions about that? This is in your textbook, folks. Is that a question? No, the constant is not equal to zero. The derivative of the constant is zero. That's what this statement is saying. That statement is saying the derivative of constant is zero. Just like y is 2. What's dy by dx? What is dy by dx? Yes. Why? Because this is ddx of 2. Derivative constant, 0. Okay. So if you all need to review your calculus, you better review your calculus. This is the calculus-based class. All right. Let me give you another example.
Dr. Cartwright, could you go back just 1 second, please? And move the paper up a little bit, please.
Oh, yeah. Sorry about that.
Okay, thank you.
What kind of graph is this? What kind of graph is this? Folks, what is that graph of?
Would it be like a magnitude response graph or something like that?
It's a straight line. Isn't it obvious it's a straight line? That's not obvious that's a straight line? All right, let's do this first. Let's make that y. Let's make that x. Because apparently it's going to take you all a little while to get used to this t and v business. But you're going to have to do it pretty soon. This is a straight line. What's the equation of a straight line?
Y equals mx plus b.
Y equals mx plus b. What's b? What's b? Anybody in high school could tell me this.
B is a constant.
What value?
10.
10, yeah. 10. B is the intercept, the y-intercept. Right there. 10. Okay. What's m? What's m?
Slope.
And how much is the slope?
15.
15. The slope is 15. The slope is 15. We don't know how to find slope of a straight line.
Rise over run.
Rise or run. Okay, here's the run. Here's the rise. What's the rise? The rise is 20. What's the run? 2. So what's the slope? 20 over 2. 10. The slope is 10. 10. Excuse me? Yeah, well, it's got to do with anything. You don't rise from 0 to 30. You rise from 10 to 30.
Oh, because that's when the graph starts. It starts at 10.
This is the rise. You go on from 10 to 30. You go on from 0 to 2. That's this point and this point. Those are the 2 points on the graph. Can't believe we don't know how to find the slope of a straight line. What is that, grade 10? Grade 11? Okay. So this is the equation of a straight line. Y equals 10x plus 10. But of course, in this class, we ain't dealing with that. We're dealing with t. Right? We're dealing with v of t or I of t in volts. And this is 10. And this is 30. And this is 0. And this is 2. So v of t equals mt plus b. We have x, you put t. We have y, you put v of t. So v of t equals 10t plus 10 volts. The voltage is a straight line. Folks, is this making sense? Any question about this? Let me do one more equation. Get me the equation of that straight line. Send me answer in chat. No, Mr. Kerr, that's completely wrong. Mr. Roll, why you send your answer to everybody?
Sorry about that. My mistake.
I should say your wrong answer. Look at that slope. Clearly that slope is positive.
Okay.
So why are you giving me a negative slope?
Oh, sorry about that.
Okay. Again, slope. Okay. There you go. The rise is what? 4. Sorry, rise is 20. Rise is 20. The run is 4. So M is 5. The intercept is negative 20 volts. So V of t equals 5t minus 20 volts. Any questions about that? Don't forget the unit, folks. Yes? Excuse me? Yo, man, just look at the diagram. Isn't that a positive slope straight line? So the rise, you're going from negative 20 to 0. You're going from negative 20 to 0. Okay. That's a positive rise. All right. Now, okay, let's do one more. Let's do one more, and that's it for straight lines. That's it for me teaching you the equation of straight line. This is a little bit harder. What's the equation of this part of the curve? That's a straight line. What's the equation of that straight line? Okay, what's the slope? What's the slope?
10/3.
Yes,
3.3.
10/3. Yes, because there's a run and there's a rise. The rise goes from 10 to 20, so that's 10. And the run goes from 3 to 6, so it's 3. So M equals 10/3 volts per second. The 10 is volts, then the horizontal is time. Okay. So V of t then, V of t equals 10/3 t plus c. I usually use c for the intercept, but if you want to use b, that's fine. So how are we going to find c?
Wouldn't that be when the line starts from?
No,
Would that be-
no. C is the y. C is the y intercept.
It doesn't.
Excuse me.
Does it? I thought it doesn't have a y-intercept because it doesn't.
Well, yeah. You extend this, and there's a slope down here somewhere. There's this intercept down there somewhere. So you could guess that it's less than 5, but how are you going to actually find it?
Is there a way that we could like transpose this equation so we could solve for y-intercept?
How you can do that? Excuse me?
Once we know v of t,
And what is V of t? V of t is the thing you're trying to find. V of t is the thing you're trying to find. We don't know V of t. We know V of 3. We know V of 6. But V of t is this equation. I don't think y'all know anything about functions. This is Math 167, by the way. We choose one point on a straight line. I'm going to go choose this point right here. What's this point right here? This point right here is what? 3, 10. Right? Isn't that point? 3, 10? So what does that mean? That means t equals 3 and v equals 10. At that point. Okay. So this is what? This is v of 3 equals 10/3 times 3 plus c. Oh, sorry. That's for this particular point. The point at t equals 3 seconds. Okay. Well, we know V of 3. What is V of 3? V of 3 means what? The voltage at time t equals 3. How much is that? That's 10. 10 equals 10/3 times 3. Okay. Plus c. So c is 0. C is 0. So I didn't draw that very well. C is 0. So V of t then, V of t equals 10/3 t volt. And let's prove that. First of all, let's put t equals 3 back there. So V of 3 equals 10/3 times 3. And V of 3 is 10 volts. 10 equals 10. Correct. Let's prove it again. Okay. Let's do this point here. Let's do this point here. What is that point? That point there is 620. So this is T and this is V. This is a V of T and T is 6. Okay. So V of 6 equals 10/3 times 6. And V of 6 is 20. Just read it off a graph. V of 6 is 20. And that's 10/3 times 6, which is 20. So that proves that this equation is correct. Let's try one more.
Dr. Conrad, you good? You could put the big block for 1 second, please. All right, thank you.
Let's try another one. Get me the equation. Copy this down real quick because I want to check my email. So I want to stop sharing. Somebody has a mic on. I'm hearing your business. Send me answers in chat. Well, I got two answers which are wrong. I'll wait for one more answer. Come on, folks. One more answer. I got two answers that says the intercept is zero. Y'all really think the intercept is zero? I mean, that graph looks like the intercept is zero. That'd be quite a, maybe I shouldn't bitch yet because I haven't worked it out. All right, let me work it out before I say it's wrong. Pay attention, please. Clearly M is rise over run. And clearly the rise is
20.
20S, 20 volts, not 20 volts. And the run is 5 seconds. So 20 over 5 equals 4 volts per second. The slope is 4 volts per second. All right, now, so V of t equals 4t plus c. All right. So choose one of these points. I'm going to choose this point right here. That point right there is V of 5 That's the y coordinate equals 4 times 5. Well, dang. Okay. And v of 5 is 20. Okay. 20 equals 20 plus c. Dang, what a coincidence. What a coincidence that c is 0. Okay, I don't want to make it 0. Let's make this 10 instead. Do this problem again and make it 10. Send me answers in chat.
Oh, the guy, we said we're doing this one at 10, right? At 10 seconds, right?
10 seconds?
What did you say? V at what? You said let's do another one.
Mr. Pinto, are you not paying attention to my class?
I just missed the last thing that you said, you see.
No, this is now the third time you missed something. You need to be paying attention to my class.
I been attention.
No, you're not, because you see it right there on the diagram?
But it may be a reason why he can't. Maybe not.
All right, okay, yeah.
Okay, pay attention, please. So the rise is now 30. The rise is now 30, and the run is still 5. Okay? So M equals, okay, 30 over 5 equals 6 volts per second. So V of t equals 6t plus c. So let's take one point. This point right here. This point right here is t equals 5. T equals 5. And V of t equals 10 plus c. Okay? So c equals negative 20. C equals negative 20. So V of t then equals 6t minus 20 volts. And let's try that. Let's try that for this point here. So V of t is clearly 40. V of t is 40. 6 times, and t is 10. Okay, minus 20. So 40 equals 60 minus 20. Yes, that is correct. 40 equals 40. No, I don't recall if anybody got that right. I'm not saying you didn't. I'm just saying I don't recall that. Okay. By the way, you can get PSpice voltage source that does this. This is called VPWL in PSpice. Anyway, why did I bring that up in the first place? Give me a second. Remember why I brought that up in the first place. Remember I said IFT equals C to VDT. That's the current through a capacitor, given the voltage. Now let's make the voltage straight line. Let's make V of T, let's make C equals 5 farads. V of T equals 6T minus 20, the one we just did. So if V of T equals 16 minus 20, what's its derivative? What's dVdt? Well, dVdt is the derivative
6.
of the first, okay, minus the derivative plus the derivative of the second. Okay. dVdt
6.
ddx of 6x is going to just be 6. Okay. And the derivative of constant is 0. Okay. Therefore, I of t would be 5 times 6 equals 30 amps. Notice if the voltage is linear, in the capacitor, the current be a constant. So we'd plot the voltage. If we would plot the voltage, where's the voltage? The voltage should be something like this. This negative 20, whatever that is. What was that? That was 40, wasn't it? Yeah. If that's a voltage across the capacitor, the current would actually be doing this. This would be the current. Okay, the current be a constant. So this is totally new to you. You haven't seen anything like this before. The only thing you've seen before is a voltage across the capacitor when the capacitor is a sinusoid. In which case you can use the phase of the main to solve that problem. Well, we can do that in time domain. Let me do that. So
Ricardo, you can put the paper back 1 second, please. Thank you.
Let's do that. And then we'll call it a day. Let's do there's a voltage. All right. And let's do the capacitor is, I don't know. Let's make it easy on ourselves. 0.1 farad. So how would you find I of t now? Without today's lesson, how would you find I of t? Well, you use phases. You would use phases before the latest lesson. And this would have been 10 and 0. Okay, and then this would have been I phasor. And this would be the impedance and capacitor. And the impedance capacitor would be negative J 1 over omega C equals negative J 1 over 2000 pi times 0.1. Okay. And how much is that? That's 200 pi reciprocal. Okay. So I phasor is V phase divided by impedance. I phase 10, 0 divided by 0.3183, negative 90. Which is 6283. Okay, positive 90, and therefore I of t, and therefore I of t equals 6283 sine 2000 pi t plus 90 degrees. By the way, that's what we did in ELT 120. But of course, you should have been able to do that from 235 as well. That's how you would have handled that before today's class. Now today's class, before I go on, any questions about that? Now today's class is this. Now today's class is I of t equals c to v dt. That's today's class. So I of t equals c. What is c? 0.1. ddt of v. What is v? V is 10 sine 2000 pi t. Okay. So that's 0.1. What's the root of a sine wave? What's the derivative of a sine wave?
Cosine wave.
Okay, but you gotta do better than that.
Minus
So the
90.
sine becomes a cosine, that's correct.
Right. And
But the amplitude stays the same, or what else happens?
you minus 90 degrees.
No. You're confusing the old method and with the new method. You're taking the derivative of sine. The derivative of sine is cosine. And by the
Right.
way, you're adding 90 degrees. Ice. You add 90 degrees. The current's ahead of the voltage by 90 degrees. So it's the 10 amplitude, that shit stays the same. And we multiply by omega. That's the rule for differentiating sine waves. We multiply by omega, and we change sine to cosine. And how much is that?
What that is after the omega?
T?
All right then.
All right. Is that the same thing we got before? Is that the same thing we got before? Yes. Why is it the same thing? Because sine plus 90 is the same thing as cosine. This is the same thing, 6283 cosine 2000 pi t. So we could do it the long phase away, or we could do it the short time domain equation. But we got to know how to take the derivatives of sine waves. Go and look that up. Be sure you know it before next class. If you have a sine omega t plus theta, then the derivative is a multiplied by omega, change the cosine. That's the rule. That's the rule that you learned. Okay. Any questions about that?
Okay, you see where the number is 6283?
Yes?
Is that sine? That's what I wanted to know. That
Is it
line.
what? No, that's cosine. I
all right.
said the derivative of sine is cosine. The derivative of sine is cosine. The derivative of sine is cosine. Anybody else? This is all in your textbook. You may have to look for it. Okay. Please go over this before next class, which is Friday. Friday, we are online. Any other questions or comments before I say goodbye?
This is our last class for the week. We'll meet on Monday. Got it.
Why this is our last class of the week?
That's how it is on the schedule.
That's what it is on the schedule.
Scheduled.
No, that's not right.
Yeah, but we only go Monday and Wednesday. Then
No, that's not right.
Well, that's what they have on the schedule.
Well, they got it wrong. It's Mondays, Wednesdays, and Fridays. This is a 4-credit class. It's 6 hours. Check your course outline. We meet on Friday at 10 o'clock. Any other comments?
Could you read the equation in the box one more time? You took it off the screen just now. All right.
Yeah, what about it?
I want to know if you could read it out one more time. I can't understand majority of that.
The first equation is the equation of the sine wave. A sine of omega t plus theta. That's the equation of sine wave. That's the equation we wrote down earlier today. Except that earlier today, A was 10 and omega was 2000 pi, and theta for the input was 0, but theta for the output was negative 88 or something like that. Well, it depends upon your number. And then the second part is the derivative of that sine wave. And how do we get the derivative? We leave A as is. We multiply by omega, this omega here, we multiply by omega, and we change sine to cosine. Does that clear it up for you? Anybody else?
Can we go back to the paper before this?
This, the old-fashioned way?
Yeah, so okay, when I put that 1 over 2000 pi times 0.1, I get that in my calculator.
You ain't getting what? The 0.3183?
Yeah, unless I remove the pi or something.
Well, let me see if I did it wrong. No, I didn't do it wrong because I got the right answer from the other way.
Yeah, I noticed that. You got the same answer, so you got it. Probably did it right. was trying to figure out what I did wrong.
I thought I got it right. Thought I got it right.
Yes.
When you finish with this, what you do now, you could put the first page of the class back on the screen.
Folks,
The one
you have to. I can't be doing this all
No,
the time.
Okay, then, but just let me ask this question. I want to know when you changed the input voltage for the homework assignment. When you changed it to phasor, I want to know you didn't convert sine to cosine when you describe the voltage in polar form. So I want to know like where you
For the homework?
Yeah, I wanted to see.
Why you had to change sine to cosine?
Oh, okay. I just want to see how you write it without doing that because I thought you didn't do that when you was working it.
But why do I have to do that when I'm working it?
You don't have to, but I just saying it would be nice to, like, include that step.
No, there's nonsense. I don't have to change sine to cosine. Here, I change sine to cosine to show you that they're both the same. You don't have to change. If you have a sine wave, you don't change it to cosine.
All right. Okay. Say you have the sine, the input sine wave in the time domain form, right? Just by looking at it, you can't write it in phasor form if you write it in cosine, right? Just by looking at it, like you could if it was just in sine.
Oh, I see you're confusing. You want to write phases based on the cosine and not based upon the sine.
I want to write it on, okay, like look at the IT, right? On this page right here. The phasor for that would be, this is in sine, 6283 at 90 degrees, right?
Yes.
Right, but if it was in cosine, it wouldn't have been so simple to see it like that.
No, you would have to convert the cosine to sine so you get the angle right.
Yeah, all right. I just wanted to see how you would do it on the first page because I couldn't remember how you write it, you see.
What first page you talking about?
When you was reviewing the assignment.
Young man, I had it in sine form. Why do you want me to change it to cosine?
I just thought, when I was thinking about it, I thought that's what I remember seeing, but I guess I'm wrong then.
Anyway, I'm out of time. I got I got a class at 12. I need a break. I'll see you all on Friday. This is $6 a week.
All right.
Okay. Let me see if I made a numerical answer.
One of my class may be clashing on Fridays.
Well, young man, you better change that. You can't be in two classes at the same time.
When we did sign up, it didn't say 3 days.
I understand that, but I'm telling you, it is 3 days. I've taught this class many, many times. This is a 4-credit class. If you can't make it 10 to 12, then you need to get rid of whatever that class is and choose another section. And you got time to do that today and tomorrow. Okay, I don't want to rush through this. Remind me to clear this up on Friday. Who asked me this question about this example?
That was me, Roland.
All right. Remind me on Friday to clear this up, okay?